Welcome back. In the last video, we did something super exciting. We saw our loss go down. So the loss is, remember, how different our model's predictions are to what we'd ideally like them. And we saw our model update its parameters through the power of backpropagation and gradient descent, all taken care of behind the scenes for us by PyTorch. So thank you, PyTorch. And again, if you'd like some extra resources on what's actually happening from a math perspective for backpropagation and gradient descent, I would refer to you to these. Otherwise, this is also how I learn about things. Gradient descent. There we go. How does gradient descent work? And then we've got backpropagation. And just to reiterate, I am doing this, just Googling these things, because that's what you're going to do in practice. You're going to come across a lot of different things that aren't covered in this course. And this is seriously what I do day to day as a machine learning engineer if I don't know what's going on. I just go to Google, read, watch a video, write some code, and then I build my own intuition for it. But with that being said, I also issued you the challenge of trying to run this training code for 100 epochs. Did you give that a go? I hope you did. And how low did your loss value get? Did the weights and bias get anywhere close to where they should have been? How do the predictions look? Now, I'm going to save that for later on, running this code for 100 epochs. For now, let's write some testing code. And just a note, you don't necessarily have to write the training and testing loop together. You can functionize them, which we will be doing later on. But for the sake of this intuition building and code practicing and first time we're writing this code together, I'm going to write them together. So testing code, we call model.eval. What does this do? So this turns off different settings in the model not needed for evaluation/testing. This can be a little confusing to remember when you're writing testing code, but we're going to do it a few times until it's habit. So just make it a habit. If you're training your model, call model.train to make sure it's in training mode. If you're testing or evaluating your model, so that's what eval stands for, evaluate, call model.eval. So it turns off different settings in the model not needed for evaluations or testing. This is things like dropout. We haven't seen what dropout is, /batch norm layers. But if we go into torch.nn, I'm sure you'll come across these things in your future machine learning endeavors. So dropout layers, there we go. And batch norm, do we have batch? Batch norm, there we go. If you'd like to work out what they are, feel free to check out the documentation. Just take it from me for now that model.eval turns off different settings not needed for evaluation and testing. Then we set up with torch.inference mode. Inference mode. So what does this do? Let's write down here. So this turns off gradient tracking. So as we discussed, if we have parameters in our model, and it turns off actually a few more things, and a couple more things behind the scenes. These are things, again, not needed for testing. So we discussed that if parameters in our model have requires grad equals true, which is the default for many different parameters in PyTorch, PyTorch will, behind the scenes, keep track of the gradients of our model and use them in loss.backward and optimizer step for backpropagation and gradient descent. However, we only need those two, backpropagation and gradient descent, during training because that is when our model is learning. When we are testing, we are just evaluating the parameters, the patterns that our model has learned on the training data set. So we don't need to do any learning when we're testing. So we turn off the things that we don't need. And is this going to have the correct spacing for me? I'm not sure. We'll find out. So we still do the forward pass in testing mode. Do the forward pass. And if you want to look up torch inference mode, just go torch inference mode. There's a great tweet about it that PyTorch did, which explains what's happening. I think we've covered this before, but yeah. Want to make your inference code in PyTorch run faster? Here's a quick thread on doing exactly that. So inference mode is torch no grad. Again, you might see torch no grad. I think I'll write that down just to let you know. But here's what's happening behind the scenes. A lot of optimization code, which is beautiful. This is why we're using PyTorch, so that our code runs nice and fast. Then we go there. You may also see with torch.nograd in older PyTorch code. It does similar things, but inference mode is the faster way of doing things, according to the thread and according to, there's a blog post attached to there as well, I believe. So you may also see torch.nograd in older PyTorch code, which would be valid, but again, inference mode is the better way of doing things. So do forward pass. So let's get our model. We want to create test predictions here. So we're going to go model 0. There's a lot of code going on here, but I'm going to just step by step it in a second. We'll go back through it all. And then number 2 is calculate the loss. Now we're doing the test predictions here. Calculate the loss. Test predictions with model 0. So now we want to calculate the what? We want to calculate the test loss. So this will be our loss function, the difference between the test pred and the test labels. That's important. So for testing, we're working with test data. For training, we're working with training data. Model learns patterns on the training data, and it evaluates those patterns that it's learned, the different parameters on the testing data. Data it has never seen before. Just like in a university course, you'd study the course materials, which is the training data, and you'd evaluate your knowledge on materials you'd hopefully never seen before, unless you sort of were friends with your professor and they gave you the exam before the actual exam. That would be cheating, right? So that's a very important point for the test data set. Don't let your model see the test data set before you evaluate it on it. Otherwise, you'll get poor results. And that's print out what's happening. Epoch, we're going to go epoch, and then I will introduce you to my little jingle to remember all of these steps, because there's a lot going on. Don't you worry, I know there's a lot going on, but again, with practice, we're going to know what's happening here like it's the back of our hand. All right, so do we need this? Oh yeah, we could say that. Oh no, we don't need test here. Loss. This is loss, not test. Print out what's happening. Okay. And we don't actually need to do this every epoch. We could just go say if epoch divided by 10 equals 0, print out what's happening. Let's do that. Rather than clutter everything up, print it out, and we'll print out this. So let's just step through what's happening. We've got 100 epochs. That's what we're about to run. 100 epochs. Our model is trained for about 10 so far, so it's got a good base. Maybe we'll just get rid of that base. Start a new instance of our model. So we'll come right back down. So our model is back to randomly initialized parameters, but of course, randomly initialized, flavored with a random seed of 42. Lovely, lovely. And so we've got our training code here. We've discussed what's happening there. Now we've got our testing code. We call model.eval, which turns off different settings in the model not needed for evaluation/testing. We call with torch inference mode context manager, which turns off gradient tracking and a couple more things behind the scenes to make our code faster. We do the forward pass. We do the test predictions. We pass our model the test data, the test features to calculate the test predictions. Then we calculate the loss using our loss function. We can use the same loss function that we used for the training data, and it's called the test loss because it's on the test data set. And then we print out what's happening because we want to know what's happening while our model's training. We don't necessarily have to do this, but the beauty of PyTorch is you can use basic Python printing statements to see what's happening with your model. And so because we're doing 100 epochs, we don't want to clutter up everything here, so we'll just print out what's happening every 10th epoch. Again, you can customize this as much as you like what's printing out here. This is just one example. If you had other metrics here, such as calculating model accuracy, we might see that later on, hint, hint. We might print out our model accuracy. So this is very exciting. Are you ready to run 100 epochs? How low do you think our loss can go? This loss was after about 10, so let's just save this here. Let's give it a go. Ready? 3, 2, 1, let's run. Oh my goodness, look at that. Weights. Here we go, every 10 epochs, we're printing out what's happening. So the 0th epoch, we started with loss as 312. Look at it go down. Yes, that's what we want. And are our weights and bias, are they moving towards our ideal weight and bias values of 0.7 and 0.3? Yes, they're moving in the right direction here. The loss is going down. Epoch 20, wonderful. Epoch 30, even better. 40, 50, going down, down, down. Yes, this is what we want. This is what we want. Now, we're predicting a straight line here. Look how low the loss gets. After 100 epochs, we've got about 3 times less than what we had before. And then we got these values are quite close to where they should be. 05629, 03573. We'll make some predictions. What do they look like? YPRED's new. This is the original predictions with random values. And if we make YPRED's new, look how close it is after 100 epochs. Now, do we print out the test loss? Oh no, we're printing out loss as well. Let's get rid of that. I think that's this statement here. Our code would have been much cleaner if we didn't have that, but that's all right. Life goes on. So our test loss, because this is the test predictions that we're making, is not as low as our training loss. I wonder how we could get that lower. What do you think we could do? We just trained it for longer, and what happened? How do you think you could get these red dots to line up with these green dots? Do you think you could? So that's my challenge to you for the next video. Think of something that you could do to get these red dots to match up with these green dots. Maybe train for longer. How do you think you could do that? So give that a shot, and I'll see you in the next video. We'll review what our testing code is doing. I'll see you there.